all right. Good day, everyone. Welcome to another session of our beginner class. Today we have our colleague here with us, Ikeme, the main G. Will be the one taking us through today's session. So today we are talking on networking. So Ikeme will be doing justice to that. Will be taking us through some of the things we need to as a DevOps engineer, because when you are working, you need to get with how your applications and how they relate or how they communicate to one another and all that, all the things that you need to know regarding the networking jargons. Okeme is going to do justice to that, right? So we have, without further ado, we won't be wasting too much time today. We'll be as fast as possible. So Keme, I'm bringing Keme back upstage. Keme, are you ready for us?
Yes. Hi guys. Hello everyone. How are you,
Right.
Simi?
All right. So please, if you do
Simi,
have questions,
you have a different
oh,
photo
oh,
there. Yeah.
I forgot to update this. So if you have questions during this session, please do well to drop it in the chat, and we would attend to your questions. Okay, May, the floor is yours. You can kickstart.
All right. Welcome guys. Welcome everyone to the beginner session of the AWS DevOps Study Group Nigeria. And today we would be talking about Linux networking. So networking is actually a very, very deep topic. There are lots of people who are specialists as a network engineer, in terms of the cloud, in terms of off the cloud, as on site and on the cloud. It's a very deep topic, and I would not be able to cover everything. This is a beginner session, so I'll take you through just so you're familiar with the terminologies, so you're familiar with some of the commands in Linux, and how to just understand the entire concept, and then we'll do some hands-on. We'll be rushing through today, so let me share my screen. Okay, Linux networking basics for beginners, uh, presented by yours truly. Yes, so let's start asking questions. We'll still get to the practical part of it, but if in terms of networking, you need to understand the theoretical parts, right? You need to understand the theoretical parts, and then that actually helps your understanding when you start doing the practical part, because in some cases it's a very abstract concept. All right, so what is computer networking? So computer networking refers to the practice of connecting computers and other devices together to share resources and communicate with each other. So what does that mean? You have a Wi-Fi, and then you have your computer, which is connected to your Wi-Fi. You have your TV, in some case, smart TV is connected to that Wi-Fi, and that connection together, all together, just devices connecting and communicating, is called computer networking. So there are different levels to it. Nowadays there's something called the IoT, so the Internet of Things, where every single device is connected to each other and communicating at the same time, sharing data and all of that. So there's a depth of it, but we'll just go over it. And then some of the fundamental concepts related to computer networking are devices, like we said, your phone, your laptops, your um, TV, and whatnot that connects to the internet or whatnot. And then we have data transmission. So when we say we have a network, it means data is being transferred from one device to another, or from one position to another. So data transmission, when this is happening, you're transferring packets of data, right? So packets of data is what is being referred to here as data transmission. Protocols, you have all kinds of protocols. You have the IP, which is the internet protocol, very popular. You have HTTP, which is hypertext markup protocol. You have HTTPS. You have FTP, file transfer protocol. So these are like protocols that are responsible for data transmission, and there are different types of protocols in computing, right? So that's for protocols, and then we have the LAN, we have the WAN. So LAN basically is your Ethernet connection, your wired connection. I think it's called large area network. I think I can't really I can't really remember the acronym, but I think it's large area network. So that is basically your Ethernet connection, your wired connection. And then you have your WAN, which is your wireless connection. Anywhere you have Wi-Fi or anything that connects and communicates without well, I won't say anything. It's basically Wi-Fi. Yes, that's what we mean by WAN, right? Because you also have some form of like Bluetooth transfer. All of that is not WAN, which is still wireless in some cases. In most cases, you have Li-Fi. There are all kinds of computer networking nowadays. So that's basically the idea: connecting different devices together and data transmission between each of them. Yep. So straight to it, IP addressing. I'm sure you've heard about the word IP address. It's a buzzword when it comes to networking. You can't mention networking without saying anything about IP addresses. All right. So an IP address is a unique numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. So it serves two main functions: identifying the host or network interface and providing the location of the host in the network. Let me explain that now. So every single device that is connected to each other has something like a unique identifying number, you know, a numerical figure, or like I said here, label that identifies that particular device. Let me give you for example now. You have a dictionary and then you're looking for a word, let's say computer. Now, to find that word in that dictionary is very easy because it is already categorized. You just go to C, and in less than a few seconds, you've already found that particular word in that dictionary. So now that's how it is in terms of computing. There are over, I think, 4 billion IPv4 addresses. And how can we categorize them? How can these addresses, how can they be classified? Do you understand? And then you have different devices. Let's say your laptop has its own IP address, your phone has its IP address, your TV has its own IP address. They are all connected to your router, which also has its own IP address. So all of that is kind of like a name or a unique identifier to labeling each device. And the two major things there, the two major functions of an IP address is to identify the host, or the network interface. That's the interface that is using, like your laptop now can be a host, and the location of the host where the your laptop is connecting to on the entire network, right? So we have types of IP address. There are two major types of IP addresses. There's the IPv6 and there's the IPv4. So IPv6 is still very much in use, but then the IPv4 is the latest kind of internet protocol. It's not so new, but it's there. But we would be focusing more on IPv4 because most modern devices, well, they both have IPv4 and V6, but V4 is kind of like the most prominent and the most used. So we'll focus on that. Next. Yes, hope you can see my screen. Let me now explain what is here. So we have IP address classes. This is a very important concept. I mean, when you see an IP address, you should be able to know what kind of class it is and why is it that class, right? So, like I said before in the dictionary example I gave, everything is categorized. You have every word in A in the A class, every word in B, Z to Z class, and all of that like that. They are all categorized. So that's how it is for IP addresses. So we have classes A to E, right? So which actually defines what kind of IP address it is. We will break all of that down. So if you notice on my first image there where I have the classes, the A class starts from 0.0.0.0, which is a 4 bit, sorry, is a 4 octets That's each unit you get is 8 bits. So we have 8 bits of zero, 8 bits of zero, 8 bits of zero, 8 bits of zero, right? Do you get? And it ends with 127.255.255.255. We will soon explain what those 255 is. And then we have class B, which starts from 128.0.0.0 to 191, right? And all. And then we have class C, which starts from 192, ends in 223. We have class D, which is 224, ends in 239. We have class E, starts with 240, ends with 225. Mhm. Good. So now there's a very popular IP address. You should know it: 192.168.1.1, or maybe 192.168.0.1.0. If you use SpectraNet or MTN and you want to check, go into your router and just check maybe change some configurations, change your password, check who is connected and all of that. That's the IP address you use. So that's the IP address of that router. It's a very popular one. 192.168.0.1, right? 192.168.0.1. Yes. All right. So and then there's localhost. I think one localhost is 127.0.0.1. I think so. I'm not too sure, but localhost too, which actually means when you are hosting a specific server or a website or whatnot on your computer locally. Yes, so it's 127. Yes, so it's 127.0.0.1. That's for localhost. Now I've mentioned all of this. Can someone just put that in the chat for me? Simi, can you help me put that localhost IP in the chat, and then put the MTN? Just look for MTN's IP, put it in the chat, and then we would use that to analyze. Yes, wide area network, local area network. Thank you. Yes, so we'll use that to analyze. Since my moderators are not doing that. Yes, so let me show this. Let me bring the MTN one too. Give it a minute. Uh, 192.168.0.1. Yes, 192.168.0.1. Now, we would talk about this in terms of like the classes now, would explain what's going on there. So we're still on that top right, top left image there. So the A and the B class are basically used as host addresses. Host addresses meaning when you're hosting a device, you get like this MTN one, the local host and all of that. You see them with 192. They start from 192 or 127. If you notice, this particular one I'm putting up here for MTN 192 actually is a class B type, sorry, a class C type, right? As you can see there now, it starts from 192 and class C starts from 192, right? So let me show you this. So this 127.0, that's localhost. So localhost now is telling you that, oh, localhost is a class A type because class A ends with 127, right? Do you get? So you see the how these things work. Once we start working, we would I'll show you different IP address. You will now be able to place them on what classes they are in. So class D and class E are rarely used, but most of the time class D is used for multicast and class E is used for experimental purposes. So once you have this diagram now and you see any IP address, just look at it and then look at the IP address. You can now define which class that IP address is in. So why do we have to classify them? We have to classify them same way you have to classify when you have a lot of things, a lot of different IDs, different numbers and everything. You have to classify them to understand which is what. So let's go back to this diagram on the low right corner. So it's telling you that the first three octets, which is the 192.168.32, that represents the network ID, right? That's for the network. While the last one, the last octet stands for the host ID. Do you understand? That's 170. Okay. So, yes, so each should I say each segment before the dot is actually 8 bits, right? So it means 8 bits in four places, eight, eight, eight. So you have 8 bits, 16 bits, you have 24 bits, and then you have the 32 bits. Okay. So yes, if you look down, still on that same image, right? Class A, you have 8 bits, right, for the network. And then you have another 8 bits, 8 bits, 8 bits for the host. So what does that basically mean? So it means if you look up there on the top left corner, you have 0.0.0.0. In some cases, you might have 10 points. Let me put that somewhere here. 10.0.0.0. Put it here. Share this. This. Aha. So what this is saying here now, you see 1, 2, 3, 4. You have three zeros at the back. If you look down on the low right corner image, you have three spaces for the host, three 8 bits for the host, and one 8 bit for the network, right? So that means that the CIDR block is what? 8, because it's just 8 bits. If you have any questions, let me know. For class B, you have 8 bits plus 8 bits, that's 16 bits for the network, and you have 8 bit plus 8 bit again, and that's 16 bits for the host, right? So it means the CIDR will now be 16. That's why you have that at the right hand corner. You have 16 there. If you notice the last one, which is class C, you have 8 bits, 8 bits, 8 bits, and then you have one last 8 bits, which is for the host. And then it means you have 24 bits for the network and then 8 bits for the host, right? So you are basically just sharing these ranges. For example, now we have 1.2.3.4, which is class A. The examples I have on the left and low left hand corner: 191.200.100.1, which is class B. Why is it class B? Because it starts from 191, right? Class B starts from 128 and ends with 191. Let's be sure about the numbers. And then we have 192.168.1.1, which is class, that's supposed to be a class C. So there's a mistake in my slide there. That's supposed to be a class C. Why? Because class C starts with 192. Do you understand? Yes. So I'll move to the next slide. There's a way to calculate most of all these things. There's a more extensive form of math in terms of checking your network ID, finding out how to manipulate subnetting, finding out which CIDR block is for what, all of that. Give me a minute. All of that all of that is, yeah. Yes, so you're finding out which CIDR block, all of that. There's a particular mathematical calculations to it. But if you just understand these ranges, the classes, and know why you have a CIDR block of 8, or why you have a CIDR block of 16, or why you have a CIDR block of 24, right? Is you just have to understand these basics, right? So subnetting, subnetting. Yes. So, like I said earlier, subnetting is the process of dividing a larger network into a smaller subnetwork or subnets, right? It's done for several reasons, including improving security, optimizing network performance, and simplifying management. What does that mean? You have a full network. I want to a large network, you can now break that down into smaller networks for reasons of security, for reasons of network optimization and performance, sometimes basically for simplifying management. So you have a network, a VPC, and then you have some subnets in it. We'll still go into subnets in a bit. And then we have CIDR notation, right? That was what I was talking about earlier. If I go back to the previous slide, you will see on the low right hand corner, you see that /8/16/24 there. Those are the sliders. Those are the CIDRs, sorry, for each of the classes, right? So CIDR basically means classless inter-domain routing notation, is a compact representation of an IP address and its associated route prefix. It is expressed as IP address slash, once you have the IP address slash prefix length, that prefix length that you have there is the CIDR block. For example, 192.168.1.0/24. So basically, that actually means, in terms of subnet max, which we'll still get there, that actually means 25.25.25.0. Right. I'll explain that in a bit, I think in the next slide. Yeah, so a subnet mask is a 32-bit number that divides an IP. The reason why I have to explain the theory is just so once we get to the practical, you can be able to relate what we are doing, right? So this is very essential. So it's used to identify the portion of the IP address that belongs to to the network, and the portion that belongs to the specific device on that network. So you use this to say, okay, this particular part is for the network, and this particular number is for your device, maybe your phone or your laptop or whatever that is connected to that laptop. So if you look at the low left corner for class A, we have that 255.0.0.0, right? Why? Because if you have this, let me bring this up again. Yeah, so if you have this 10.0, if you look at this comment down here, 10.0.0.0, the places where you have zero are actually zero values, right? And the places where you have actual numerical value, like the 10, is where you have the 255, right? So that just shows you that, okay, that particular part of the 10, which is the 255, belongs to the network, and the 0000 belongs to the host, right? If you go to class B, you have 255.255.00.0.0. That's 0.0 belongs to the device. 255.255 are actual numerical values belonging to the network, right? So if I show you this now here in the comment, I think it's called the comment on this box down here, 192.168.0.1. Now that's a class C. Why? If you look at 225, 225, 225, they represent 255.255.255. They represent this 192.168.0. And then this last place where you have a zero represents the one that is right here, right? So which is just telling you that one belongs to the host, while 192.168.0 belongs to the network. Okay. So if you look at the diagram on the right, that actually breaks it down in terms of like binary. So you see that this is a mathematically involved thing, right? So if we break the IP address down, we are looking at the diagram on the right, 1932.168.123.132. What you have underneath them are the binary equivalent, right? And the first three octets belongs to the network ID, and the last one belongs to the host ID. Everything is what, 32 bits, right? So if you look down, you now have the representation of the subnet max, right? So 255, sorry, represents these ones here. The other 255.11111, the other 255.111, and 0, which is the host ID, is what? 0. Do you get? So that's basically how to kind of like should I say, interpret your subnet marks related to your IP address. Time. I have to get to the practical. Uh, yes, so this is a very important part now. Once you start doing AWS, in terms of networking VPCs, this is a very important part. There's a private subnet and then there's a public subnet. So private subnets are basically is like an internal network. It's not connected to the internet, right? It's just, if you use Kubernetes, let me not even go straight to Kubernetes. That's too far. It is just a private network where it is not connected to the internet, but the devices inside that private network can connect to each other, such as those in your office and your corporate intranets, right? Do you get? So right down there is the class for private IP addresses, and then everything, when you subtract all this private after the when you subtract all this private IP address, every other thing belongs to the public IP address. So the public IP address is basically connected to the internet, right? It is, on the other hand, an IP address that is global and accessible to the internet. Devices in public subnets can communicate directly with the internet and can be accessible from anywhere on the web. Let me go back to the private subnets now. So those private subnets here, remember, something from the outside world can't connect to it. That's why it's private. It's only for the insiders. Imagine you have an office, you have two office buildings on your street. One office building, nobody comes outside, everybody is communicating inside. That's your private subnet. You have another office building on the other side of the street. People come outside and go out, go out, go in. Anyone can communicate with it. Anybody can go inside, anyone can come outside. That's like a public subnet. It's open to the public, like the name implies. In some cases, there are like firewalls you can put in place. There are like traffic rules, security groups you can put in place, even if it's a public subnet, to prevent some kind of network or traffic from coming in. We'll get to that. So DNS configuration. So what's DNS configuration, right? What's DNS self? So DNS stands for domain name system, right? For example, www.ukeme.us is a domain name, is a DNS. When they say what's the DNS, it actually just means what's your website name, right? www.google.com is a DNS, right? So it's a hierarchical system and protocol used to translate user-friendly domain names to numerical IP addresses. So everything google.com actually has its own IP. We'll check that in a bit. Ukeme.us has its own IP address, and all of that. So there's basically something called a domain resolver. So a domain resolver is basically, should I say a server? I'll say a server that basically converts that www.example.com or ukeme.com, the DNS, into the IP address, because the computer actually would understand those IP addresses, so you need something to convert it. That's where the resolving comes in. So this is a practical part. Now I'm going to share my screen and let's just run through this. What I wrote there, edit etc resolve.config. I will explain why we're doing all of that. So let me share my screen. Okay, so I have a specific, wow, okay, it's out. I have this light sale account. It's actually a live account. It's actually a live website. Show you so you know. Okay, something live. So there's this website, peertravels.ng, and it's actually hosted on AWS Lightsail. So what I'm going to do is to SSH into this Lightsail instance, and then we can play around there. We won't break anything. We won't do anything too serious, but just to show you what we're talking about. Yes, so if you have been following our other classes, you'll know how to SSH. So basically, my command there is ssh-i, and then this light seal default key is actually the key that does the authentication. The bitnami is the name of the user, and then this 13.37 points, all of this is what the IP address. And if you are looking at this IP address from what we've just learned, this is a class A IP address because it starts with 13. Remember, class A ends in, let me just quickly check. Let's quickly check that. So class A, I mean, you can't cram all these numbers now. You can't cram everything. So class A ends in 127, right? 127. So if we look at this, you see, so it ends in 1 to, this is within the range of a class A IP. So if I go in there, try to SSH into that device, yeah, so we're in. And then what that slide was saying is you can actually add a domain resolver in your system, right? So is usually in this folder. So if I cat /etc slash resolve.conf, you can see what we have here. We have this domain from EU West. These are like AWS resolvers, right? These are AWS resolvers. If we look at this here, 172.26, we can actually put that as a class of class B, I think, as a class B. If we check there, this is 172. So 172 is in a class B range because class B is 128 to 191. So you get, now you can kind of like figure out these things. Okay, so I go back here and this is it here. These are like the domain resolvers. They resolve the domain. Anytime I try to go to a specific website, it's going to resolve it. And this is the domains that actually, the servers, or should I say domains that resolve them. So if I want to edit that now, I can just do a nano, and then I go into that file, which is in the etc resolve.conf, and then I can add Google to it, right? So Google, I think Google is a name server for on 8.8.8.8. So that's Google's name server. I can just add that to it, even if we have others. I'm just showing you. So I'll save that. Okay, permission denied because I didn't use sudo. So I will try that again with the sudo command. Let's put that there. Name server 8.8.8.8. Yes. If we cut that file now, you should see that there, right? So it's there. So you follow my tutorial, follow my, yeah, where are we? Okay, so what we just did there was just to add a new IP address as a domain resolver in our Linux machine. And then once we've done that, we can now restart the network and then test a DNS configuration. So in terms of restarting the network, we will do that. If you, this might be a bit advanced for some people, but something called system. I will give you sudo. Sudo means super user do, and then system CTL. That actually means system control. You're trying to control some of the services in the system by saying let's restart. So because we've updated our etc/resolve.conf file, we now have to restart the entire system for it to take effect. So restart, I think system d dash network d. So these are the services. So we started that now. We can now start talking about troubleshooting on network configuration commands, right? So there's a couple of them. There's ns lookup, I say ns lookup ukeme. That's my website, by the way. You can check it out. Ukeme.us. Right. So it's now bringing this information now to us. That okay, we've tried to resolve this ukeme.us, and by resolving it, this is what we get. 172.26.02. So this is actually my own server that is actually this computer that is making the request, to look up that particular ukeme.us IP address. So if you look at this here address, is the same thing here, but then we have a hash 53. So hash 53 actually, the 53 there actually means the port that this particular server is using to do the lookup, right? So we have a non-authoritative answer. This non-authoritative answer actually means, okay, so we didn't it's trying to tell you that we didn't actually get to the actual IP address that is housing that resolved that houses ukeme.us, but we got this answer from a cached result. Do you get me? They didn't go straight to it, but they got it from a cached result, right? So ukeme.us, this is the IP address of ukeme.us. We can also play around with something called dig. I've forgotten what dig stands for. I can't remember, but it's also one of those tools you use. So if we do dig ukeme.us, it gives us more information, right? So we see now dig is making the requests of to ukeme.us through this Debian machine, and then it gives you some figures, and then this is the answer, ukeme.us, and this is the IP address. So these are two ways you can use ns lookup, you can use dig. Dig basically just gives you more information. That's if you need them, like when you made the query and whatnot. So I'm going to stop here. I'll go back to my presentation. So what we basically did was that, okay, we looked for the DNS resolver file, which is resolve.conf in the etc folder. We added Google there to be a DNS resolver, and then we now restarted the entire system service, which is the system service for the network, and then we had to do some troubleshooting or just checking by using DNS ns lookup and dig, right? Those two commands, uh, uh, that's what we use. So let me go back to the presentation. Pull this off. Yes, so that's what we did here. We restarted the network. We used this command to restart, and then we tested it using dig and ns lookup. Yes, so network troubleshooting. So these are kind of like, I use these a lot. In fact, I use them every day. I'll show you. Um, Let me just explain this. So ping uses ping to check if a remote host is reachable. So if I want to, sometimes if you actually if you are connected to the internet and you want to check if your internet is going, if it works, if it's slow or it's fast, I use ping. I'll just look for maybe google.com or ukeme.us, any website. I'll just try and ping it. If I get a request timeout, I know my internet is bad, the network is bad, and then I start checking the speed. I'll show you. I start checking the speed because that speed now determines how fast my internet is. So I have an idea. Instead of me going to, you can go to fast.com, for instance, to check all those things. But with ping, I can check in real time, and I just keep it running infinitely. I'll show you. And then there's use trace route. Trace route or trace RT is used to trace the route packages, take it to use trace the route packets before it reaches the destination, right? So if I say I'm going to www.google.com or keme.us, it takes it doesn't just go straight to that server and then bring that information from the website. It's going to hop from where you are to one server to another server to another server until it gets to the server that has the request you need. Then it hops back, and then gives you that website the request right? So it's a request response thing, So you use traceroute to check how the route packets are moving till it gets to its destination, right? So and then we have network diagnostics. Use these tools. So we have tools like NetStats. We'll still check that too in practice. We have NetStats. Let me write it somewhere so I don't forget. So we'll check ping. We'll check trace routes. That's trace RT. We'll check NetStats. We'll check TCP dump. In terms of Wireshark is basically a networking device. A networking software. So we're not using anything Wireshark right now. So we'll do ping, which is used to check if a host is reachable. We'll use traceroute to check the destination of the packages. We'll then do some network diagnostics using the tools like NetStats, and then we'll do a TCP dump used to capture and analyze network traffic. All right, so let's do that now. Share my screen. So in terms of ping, as you can see there, I use ping. This is what I do with ping. I use it a lot. I just keep it running on my Windows system. I can use it on Linux too. I just keep it running, and as you can see, let me see if I can. Oh, let me do it here. I'll just close this. I'll ping. So how to use it is just ping ukeme.com or ukeme.us, my website. And then, as you can see, it's trying to ping. It brings out the IP address and the amount of bytes that it has pinged. I don't know why this is taking time, but let's do it on Windows. If I do ping camera.us. Okay, now so this actually means, okay, so you see now, it means it can't reach it can't reach that particular IP. That's why it's saying request timeout. It can't reach the IP. The IP is currently, or that particular server is currently not available at the moment. So you say four packets sent, 0 received, lost, all of them lost. So it's a 100% loss. Let's do a ping youtube.com. Yeah. Let me do it on Windows because I think there's more clarity here. Do it on Windows. Ping -t ukeme, sorry, youtube.com. So this -t I added there, that actually means you should continue making the request. So don't stop. Remember the first command, I didn't have the -t there, so it just made four requests and then stopped. Sent 4 packets and then stopped. This now would continue until I stop it. I don't know why this is doing this here, but it's still the same thing here. It will continue until I stop it. So if I stop now, we now look at this last, what is saying, I sent 49 packets of data. I transmitted 49 packets of data. I received 49 back. 0% was lost, which is perfect. And this is the time it took, right, for me to make that request. So that's basically what you use. You use it to check a host if that host is actually available or not. And if I leave this here and then I start seeing request timeout, it's two things. It's either there's something wrong with the server or okay. Okay, so it's either there's something wrong with the server or the internet is bad. You start seeing request time, or there's something wrong with my network, it's not working. You try and reboot. So you use that to make informed information. What's the next one? Trace RT. Now, I said something about hops when you make a request. So these things just it brings us back to the idea of APIs. You are making a request, you are getting a response. Do you get? So let's now make a request. Let's do a trace route. Trace route of trace RT of okeme.us. Oh, that's the command now. Trace RT. Yes. Trace RT. I'm turning something off. Check. Okay, so I'm wondering why it didn't work for this particular. I'm wondering why it didn't work because let me check. Uh, Maybe it's because this is a Debian. Maybe because I'm not too sure, but I think it's because it's a Debian distro. That's why this trace RT didn't work. But if it's Ubuntu, I think it's meant to work. So I'm going to. Okay, this is still working. So let me just explain this here. It's still the same concepts. So it's saying that in the first hop I made, 2 milliseconds, I made it to this. This is the IP address I was in, 192.168.0.1. So this now is my MTN. This is my MTN's router. You see, from there I jumped to this. From there I jumped to this. From here I'm trying to get the request, but the network is bad. And then I jump to this. Let me put YouTube. I think YouTube or Google should work. Should be fast. So what this actually means is that in terms of networking is once you make a request, you are trying to go to a particular website or you're making a web request, it doesn't just go straight to that server and then picks it up. It's going to make a hop from different servers, especially if maybe the file is hosted somewhere in the US and you're here in Nigeria. It's going to go through almost around the globe to go and get your data and then come back with a response, right? So that's why AWS has something called availability zones and regions. So if this server now is somewhere in the UK or somewhere in Nigeria here, it probably will just take 3 hops. But since it's going to, I don't know where this Google server is, probably in the US, it will make close to like, this is saying the maximum of 30 hops just to get there and then come back. So that's why sometimes you are trying to query some data and it takes time. So I'm going to move on from here. The next one is netstat. Let's do netstat. So in terms of netstat just basically gives you connections. It gives you an overview of your entire, network, right? So you can check all of this is just a lot of information and we can't go through everything, but it gives you all the information concerning your network. So which other one? Okay, so some well, trace routes. Let me see. Trace routes. Oh, okay. So for for Debian is trace routes, not trace RT. So if I do trace route for MS, US, yeah. So it's trace route for Debian distro. Okay. So this is taking a lot of hops, which tells you that My server is not in Nigeria. But anyways, let's go back here. I'm going to stop sharing. Okay, which one did I miss? Okay, so TCP dump is used to capture and analyze network traffic. Let me show you this. Let's do TCP dump. Oops. Let's use sudo. So you see, this is going to take forever. It just keeps going. So this is not the best thing to do. What you should do is that you should now take this old network, everything, the network traffic data, you can maybe just pipe it down to a text file. So you can now read that text file. If I say TCP dump, and then I do this, and then I say traffic.txt sudo. It's basically going to write to that file. If I come here now, let me go into that server from here. Because the reason why this is still like this on the left hand side, because it's still adding data to that file. But I can now read it. I can read what is there from here. Ls, so we have that file there, traffic.data. If I do cat traffic.text, sorry. Okay, so I spelled this wrong. Yeah, so you have all of that in a file and it keeps writing to that file. So that's the best way to actually save this data. All right, so I'm going to stop this here and then let's go back to our slide. We're meant to round up by now. We just rush through. Yeah, so what's next? Firewall management. So firewall management is basically beyond the scope of this, but we just have to go through all of this. I'm going to show you something before we get to this. Let me show you something on AWS about security groups because that gives you a visual understanding of what's going on. So I have this instance here. I'm going to open an AWS one. I have this instance here. And if I check the networking here, you see we have firewall IPv4, we have IPv6 networking. So for this IPv4, it's trying to tell you that, okay, we have this SSH, which is secure shell. We have HTTP, which is hypertext, normal HTTP, www.
Yeah, so I will just take over from where Kenneth stopped. This is having a bit of network issue. We're almost at the end of this session, so let me just go over things he has mentioned. So he was talking about yeah. So he has spoken about how we do network troubleshooting, how you do your ping to check network availability, and also do a network diagnostic using the NetStat to TCP dump wires check. I just also mentioned these are just few of the commands that you could use. There are some other commands that also come in handy, like the netcat command, which you could also use to trace and uh, to trace your network reachability or availability, right? So so we also have the firewall management, which is the IP tables. So just like the way you have your security group on your on AWS, right? You could also have a kind of security on your on your server or on your Linux environment. So this is where your IP tables come in. So also on so there are so many security that you could use. You could use IP tables. You could use the for people that are familiar with Red Hat, you could use the firewall D. Could also use the UFW firewall. So there are so many of them you could use to trace to block or to permit or to disable whatever permission you want to use. So what most people do, right, on their in cloud, right? If you are running on cloud, they don't. Most organizations which I've seen, they don't really put much emphasis on on the firewall on the server. They allow your security group to handle that, right? So, but if you are like running an on-premise environment, whereby you need to manage this firewall, then these commands would really come in handy, right? And then the last part is so I believe this is all. This is all the question. Please, if you have questions. So someone mentioned something regarding trace routes on Linux. Yes, on Linux system it is trace routes. On Windows it is trace sat. Yeah, trace RT, right? While on Linux you have it to be the trace route. If you want to do the trace route on the Linux environment. Yeah, so sometimes you might not have this trace route installed. You might be seeing the command not found when you are running a Linux environment. So what you could do is you would just need to install that trace route package into your Linux box, right? What again? I'm trying to see if I could bring up my VM. So we could just run through the IP table. But the VM is it's not coming up. Not coming up. I'm having issues bringing up my virtual environment. I would have just loved to show us these IP tables and how it works. So majorly it's just these commands that you have. So let me just explain this command that he has, this allow incoming traffic on the specific ports. So in this case, you want to allow traffic on port 80, which is for your web server or your application that runs on port 80, right? So this is how you do it. You just so this is as you mentioned earlier, you have to use sudo if you are not the root user. So because these commands require root privilege to work. So you just need to input that and just type the sudo IP tables then the -a flag, then the inputs, then the P, the, the protocol you are using, then the destination port, which is the D port, then the rule you want to put append to it, which is the last part, which is the either you are saying accept or deny. So you could say, oh, you don't want to deny. By default, if you don't specify a rule, if you have your iptables enabled, right, and you don't specify it to accept or deny a particular rule, it will automatically deny that rule. But once you specify that it should accept, then it's going to accept that rule. So that's why most, like I mentioned, most organizations you see, they don't bother about them configuring iptables on their EC2 instance, right? What they do is they make use of the security group, which is also doing the same functionality to permit or to allow or deny. So by default, all connections are the same principles too applies to the Linux and to the security group too. If you don't permit anything, by default everything is blocked. It's only when you open a port or you permit a port on your security group that it will be allowed. Right. So that is all for today. Thank you all for joining. If you have any question or if you have any any other stuffs, any other questions, please drop your question. And you could also reach us via our group chat. We'll be sharing the link of the group chat. So if you have other questions regarding this topic, you could you could also drop it in that chat. So be sharing the chat in the chat session shortly. So thank you all for tuning in. It's been a wonderful time, and see you next time. So our next session will be on Saturday, where we'll be talking, where we have another speaker take us through the advanced session. So thank you all, and do have a wonderful day ahead.